Did you know that poorly crafted prompts can lead to 95% inaccurate or irrelevant responses from GenAI models? Companies like Netflix see this daily when recommending movies. Here's what most developers get wrong. They treat prompts as simple instructions. By the end of this video, you'll master advanced prompt engineering techniques like few-shot learning, chain of thought, and RAG to build GenAI applications that deliver accurate, reliable, and secure results. We'll dive into the strategies that separate hobby projects from production-ready AI. Remember this 95% number. It comes back later when we discuss prompt evaluation.
Now that we've established the stakes, let's cover the core concepts. First, Time's few-shot prompting provides the model with a handful of examples to guide its response. Think of it like showing a student a few solved problems before asking them to solve a new one. Then there's the crucial distinction between Time's system prompts, which define the model's persona and constraints, and Time's user prompts, which contain the specific query. Think of the system prompt as setting the scene, and the user prompt as the action within that scene. Building on that foundation, let's introduce two more powerful techniques. Time's chain of thought prompting encourages the model to break down complex problems into a series of intermediate reasoning steps, leading to more accurate answers. This is especially useful for tasks requiring logical deduction or multi-step calculations. Think of it like showing your work in math class. Time's Retrieval Augmented Generation, RAG, enhances the model's knowledge by grounding it in external data sources. RAG combines the power of LLMs with the vast information available in vector databases or knowledge graphs. This allows the model to generate more informed and contextually relevant responses. The reason RAG is so powerful is because it overcomes the LLM's inherent knowledge limitations. Stop. Think about this. These concepts are the building blocks for advanced prompt engineering.
With the core concepts in place, let's dive into how Time's chain of thought prompting works under the hood. It relies on carefully crafted prompts that guide the model's reasoning process. The key is to provide clear and concise intermediate steps. For example, instead of asking, "What is 17 times 23?" you'd prompt, "First, what is 17 times 20? Then, what is 17 times 3? Finally, add those two results." This breaks down the problem. An experienced interviewer will probe, why not just let the LLM figure it out? The answer is that for complex problems, guiding the reasoning improves accuracy. We use chain of thought because it mimics human problem solving.
Now, let's examine Time's Retrieval Augmented Generation, RAG times, in detail. RAG involves a multi-stage data flow. First, the user's query is embedded into a vector representation. This vector is then used to search a vector database for relevant documents, using algorithms like FICE for approximate nearest neighbors. Finally, the retrieved documents are combined with the original query and fed into the LLM to generate a response. The reason RAG is so effective is because it overcomes the LLM's inherent knowledge limitations. Companies like Google use RAG to enhance search results. Next, consider Time's self-consistency decoding times. This technique generates multiple candidate responses from the LLM and then selects the most consistent one. It's like asking several experts for their opinions and then choosing the answer that most of them agree on. This process improves the reliability and accuracy of the generated output. The reason this works is that LLMs can sometimes produce inconsistent or contradictory responses, especially for complex tasks. Self-consistency decoding helps to mitigate this issue by leveraging the collective knowledge of multiple generated outputs. Here's the twist. This technique is especially useful when combined with chain of thought prompting. This sets us up for the hands-on walkthrough. Let's get our hands dirty with some code. We'll use LangChain to demonstrate Time's prompt ensembling times. First, define multiple prompt templates, each with a slightly different phrasing or focus. Then, use LangChain's sequential chain to combine these prompts into a single pipeline. Finally, pass the user's input through the pipeline to generate multiple responses. The mistake most developers make is relying on a single prompt template. By ensembling multiple prompts, you can improve the robustness and accuracy of your GenAI applications. Here's how it looks in Python.
Here's where it gets really powerful. Let's add RAG to our prompt ensembling pipeline.
We'll use LlamaIndex to connect to a vector database containing relevant documents. First, create an index from your data source. Then, define a query engine that retrieves relevant documents based on the user's input. Finally, combine the retrieved documents with your prompt templates to generate a response. This is all it takes to build a GenAI application that leverages external knowledge. What could go wrong? The most common issue is poorly designed retrieval queries that return irrelevant documents. Make sure to carefully tune your query engine to maximize retrieval accuracy. Now, let's talk about best practices for productionizing your prompt engineering workflows. Times, prompt versioning, is crucial for tracking changes and ensuring reproducibility. Treat your prompts like code and use a version control system like Git. Times, prompt security is another critical consideration. Always sanitize user inputs to prevent prompt injection attacks. Use delimiters to separate the system prompt from the user prompt. An experienced tech lead will push back. Why not just rely on the LLM's built-in security mechanisms? The defense: LLMs are not foolproof. Prompt injection attacks are constantly evolving, so you need to implement your own security measures. We use Git because it provides a robust and auditable history of changes, unlike ad hoc methods. Finally, Times prompt evaluation times is essential for objectively measuring prompt performance. Use metrics like accuracy, relevance, and coherence to assess the quality of your generated outputs. Don't rely solely on subjective evaluations. Use automated evaluation pipelines to continuously monitor and improve your prompts. This is the part most tutorials skip, and it costs developers hours of debugging. Remember that 95. When should you use these advanced prompt engineering techniques? If you're building GenAI applications that require high accuracy, reliability, and security, then these techniques are essential. But what are the alternatives? Active prompting involves iteratively refining prompts based on user feedback. Prompt optimization uses algorithms to automatically generate and optimize prompts. The key insight is to experiment and find the techniques that work best for your specific use case. We use active prompting because it allows us to adapt to changing user needs and preferences. Remember that 95% inaccuracy rate we talked about at the beginning? By mastering these advanced prompt engineering techniques, you can dramatically improve the performance of your GenAI applications and avoid that pitfall. Now go build something amazing. If you found this video helpful, please like and subscribe for more GenAI tutorials.
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.